Right, so we're going to be looking at question 7. Now, question 7 is very standard. Right, and we analyze it together. It is about a landscape artist that plans to plant flowers within 2 concentric circles around a vertical light pole PQ. P is a point on the inner circle and S is a point on the outer circle. S is on the outer circle and R is on the inner circle. So the 2 circles, concentric circles mean circles which have the same center. R is a point on the inner circle in that. Okay. R, Q, and S lie on the same horizontal plane. So can be rest assured that R, Q, and S lie on the same horizontal plane. RS is a pipe used for the irrigation system in the garden. So if RS, that becomes a pipe there. Okay, right. The radius of the inner circle is R units. It has been shown to be R units. And the radius of the outer circle is QS. You have Q and you have S. The angle of elevation of from P to S is 30 degrees. From S to P is 30 degrees. Okay, from S to P, that angle of elevation is 30 degrees. RQS is 2x. Right, so you have RQS is actually double x. And you have PQ equals the square root of 3 R. Okay, square root of 3 R. Okay. Right, so we're looking at question 7.1. The examiner is saying, show that QR is exactly that one. Right, let's just proceed to do that a little bit there. Okay. Right, to do this question, there are a couple of things you need to bear in mind. So to show this, we'd have to look at the fact that we're dealing with this particular triangle that is QS in it. So you have your QS, this is Q and that is S. And therefore this actually becomes P. This angle is 30 degrees. This is 90, square root of 3, then R. Which means we're dealing with the opposite angle, and in view of our frequently used mnemonics or katoa, we have the opposite in the adjacent we're dealing with, which is the tan. So we're going to use the tangent of 30 degrees, which becomes actually the opposite. Okay, so if it is the opposite, we'll have the tangent of 30 degrees, which is opposite to the square root of 3R, over the adjacent, which is QS. And then, which means QS is the same as you cross multiply, which is the square root of 3R divided by the tan of 30 degrees, which is the square root of 3R. What is the tangent of 30 degrees? Right, the tangent of 30 degrees, we remember our special triangles. So we have this is actually 30 degrees here, 60 degrees there, the square root of 3 here to 1. So that the tangent of 30 degrees is the opposite of the adjacent. Okay, if it is the opposite over the adjacent, then this is the square root of 3, then R, which is 1 over the square root of 3, square root of 3, 3R, which means QS is 3R. In if the examiner wanted this to be shown. Right, so the next question is 7.2. Determine in terms of R the area of the flower garden. So now the area of the flower garden, which is the region formed by these concentric circles which share the same center, and therefore to find the area would have to be the outer area minus the inner area. So what we do there would then say the area is equal to the outer area minus the inner area, which means the area is the outer area, which is you can write it like pi radius squared. If I'm to call, for argument's sake, this bigger radius from the center to the boundary of the bigger circle, you call it big R, and then the one from the center to the boundary of the smaller circle, you call it small r. So that is going to be pi big R squared minus pi small r squared, and therefore the area becomes the big R, so it's going to become QS, and QS we've just found is actually this one here. So which is pi into 3r, you square it minus pi r squared. Pi into, you squared it 3, you get 9r squared minus pi r squared, which means 9 pi r squared minus pi r squared, which means 8 pi r squared. So which means the area is actually 8 pi r squared there. Okay, that's something you need to just note. Okay, so we continue and we actually analyze these questions more. We proceed to look at the next question, 7.3. Right, so in 7.3, we're going to proceed as follows. Right, so in 7.3, we have a couple of things to consider. We have to show that RS is this. So if RS is the square root, where is R and where is this is R and that is S, and we need to just find the length of that. And now it relates to 2x, which is there. So it's clear that you need to work in one of the triangles here. So you need to work in triangle RQS. What is this? Which means RS squared. Sorry, we can do this, yeah. So RS squared is equal to R squared, which is this one, plus big R squared, if you like, and then minus 3R big R minus 2 R big R cosine of the angle 2x, which is the angle opposite this side RS, and this is the law of cosines or the cosine rule. So RS squared is the R, so it's going to be small r plus this big R is the same as triple R minus 2R into 3R cosine double x, which means that we have RS squared because R squared plus 9R squared minus 6R squared cosine 2x, which means RS squared is 10R squared minus 6R squared cosine 2x. Therefore, what is this? Right, you can pull out a common factor so that R squared is the same as the common factor is R squared into 10 minus 6. Right, into 10 minus 6. Cosine 2x. Which is minus 6. And the square root of R squared is just R. And then you have the square root of 10 minus 6 cosine 2x. Right, we've done 7.3 there by using the cosine rule, or by using the law of cosines. 7.4 now, we're going to look at the next one, RS. So if R is 10 meters and X is 56, so if R is 10 and X is 56, you can just find the length of RS. So you're going to proceed to do that one. So we're going to do 7.4. So that one is straightforward. RS is R into the square root of 10 minus 6 cosine 2x, which means RS. Okay, we know that R is 10, so just do substitution. 10 minus 6 cosine of 2, x is 56 degrees. And therefore, we get the answer. The answer becomes 34.9966. RS is 35 meters. Okay, so this one here is the answer. So we found RS there. Okay. Right, so the next thing, we proceed to look at question 8. And question 8 is about, right, O is the center of the circle, and KOM bisects LN. Right, so you have KOM, it bisects LN. M and O is 26 degrees. M and O is 26 degrees. K and P are points on the circle with NKP equals 32. OP is drawn. OP is just drawn. Okay, so this is the sort of diagram that we have. Okay, let's analyze this and think about what we need to do. Right, so we are looking right now with the solution to question 8. And question 8 is a very interesting question. So we're going to be focusing on 8.1, 8.1.1 to be more specific. Okay. What do we do? So you need to determine, giving reasons the size of the angle O2. You need to determine, giving reasons the size of the angle O2. Right, determine that one. There's a theorem we need to use. Angle at center is twice angle at circumference. There's a center that is involved, and we have something like this. So this theorem can also be written like this. Angle at center is twice angle at circumference. So if this is A, O, B, C, we then say the angle at center is AOB, which is 2 times ACB. Angle at center is twice angle at circumference, in which case it can be applied here also. AOB, then C. In other words, this C can be moved. If it's here, it can be moved to a position that is here. Can swing it around so that it sits like there. And at that point, we are sure, therefore, that the angle at center is twice angle at circumference, or we can be sure that angle O2 is twice angle K1. And the reason for this is that angle at center, right, angle at center is equal to 2 times angle at circumference. Now with this, then we say angle O2 is twice K1, which is 32 degrees. The reason here is that angle K1 is 32 degrees. Why? Because it is given that way, which is 64 degrees. What is angle O1? Determine giving reasons the size of angle O1. Okay, so O1 is an angle at center. And then now we just need to find this angle O1. Okay, right. How do we get angle O1? A couple of things, because we already know that first we note that angle M2 is equal to 90 degrees. Why? Because of the line from center to midpoint of chord. Line from center to midpoint of chord. This line is from the center to the midpoint of the chord, and therefore it is perpendicular to the chord. Midpoint, because these are equal. So that's why M2 is actually equal to 90 degrees. So we proceed to find some of the angles, like we can be able to find the angle, this one. So if you look at these, then if you have a triangle like this from grade 10, and then you have this. Okay, an angle here is going to be, for example, this one here is an angle, and this is 26 degrees. So we note, therefore, that this is an exterior angle of the triangle. So which means angle KON is equal to 90 degrees plus 26 degrees. And now, why is this? Because the exterior angle of triangle, the exterior angle of a triangle, we already know that it is equal to the interior opposite angle. And therefore, which means KON, add these two guys, which is 116 degrees. Okay, if this angle is 116 degrees, what is angle O1? So we proceed to say this. Angle O1 is 116 degrees minus 64 degrees. Because you already know that angle O2 is 64 degrees, so you already know this one here is 64 degrees. So we can say 116, which is everything here, minus 64 degrees, which means therefore angle O1 is the difference, 52 degrees. Angle O1 is 52 degrees. All right, so we found it. Angle O1 is 52 degrees. There. That's what they wanted. Right, so we continue. Now this was 8.1.1, so this was 8.1.1a. And this was still 8.1.1, but it was 8.1.1 B part. Now we continue to look at more questions and to solve more problems. Proof giving reasons that Kn bisects OKP. Let's analyze that one. So if you look at the angle at the question 8.1.2, proof giving reasons that Kn bisects OKP. Kn, so here is K and here is N. Bisects OKP. Proof giving reasons that Kn bisects angle OKP. So you have OKP. So you must prove that this is equal to this. Okay. So you must prove that K2 is 32 degrees, for instance, because K1 we already know is 32 degrees, right? So to prove that one, we note that we can deal with some of the angles in triangle because we have knowledge of this. So we can say angle PKO, angle PKO, this one, plus angle P, this one, is equal to 128 degrees. Because you already know that O1 is, we already got angle O1 to be 52 degrees. So you already know that this one is 52 degrees. So which means you have the sum of angles in triangle. Okay, so then, because you already know this one is 52, so which means, therefore, if you add this one and this one, you would get 128 because the sum is 180 degrees. Right, so sum of angles in triangle. Moreover, angle PKO must be equals to angle P. Angle PKO, this angle must be equals to angle P because of the fact that you have the angles opposite equal sides. So, which means if these angles, if you add them up, this one and this one is 128. So which means angle P is 128 and you divide it by 2, and this is 64 degrees. So PKO is 64 degrees. And therefore, if you come here, you will observe, therefore, that K2 is 32 degrees. Because, and this one is 64 degrees. Because angle P is 64 and this is 64. But this is already 32. This can only be 32 because 32 plus 32 is 64. Now, let's see what we're getting with this and where we're getting with this. Well, I mean, the implication out of this is that angle K2 is actually, so the conclusion therefore is that angle K2 must be 32 degrees. If this is 64 and this is 64, this is 64, but this is already 32, this can only be 32 degrees. Goodness me. Okay, K2 equals K1. K2 equals K1. You can say K2 is 32 degrees or K2 equals K1. The fact that K2 equals K1, the fact that K2 is equal to K1, I mean, it means therefore that therefore Kn bisects PKO or OKP. Kn bisects OKP. Okay, so we had to prove therefore that Kn bisects OKP, and you can see that Kn is this one here. It bisects OKP because it cuts this angle into two equal angles. Okay, that takes us to the end of question 8.1.2. And then we move on to the 8.2 part of the exam. This exam was written during the year 2020 by the matric students. Let's see what the students had to do there at matric. The trial exams heard that they're starting very soon, very likely around the 28th of this month or something like that. So the prelims are here. The prelims are here for you guys, so you need to be ready. And we are preparing now. And we're going to be looking at science as well during the course of the week, and looking at the exam overview and how we can reflect on the entire syllabus for math and science to ensure optimal results. In triangle ABC, we have F and G are points on the sides. So we have that F and G are points on the sides of AB and AC respectively. D is a point on GC. D is a point on GC, such that angle D1 equals B. Angle D1 equals B. They've been marked that way. So, good. Okay. We continue. If AF is a tangent to the circle, so you have AF is a tangent to the circle passing through points F, G, and D. F, G, and D. And this AF is a tangent. So in other words, there is a circle that passes through the points F, G, and D, and therefore we're assuming that this one is a tangent. Okay, something like that. Then prove giving reasons that FG is parallel to BC. So we need to show that FG is parallel to BC. Okay, if these two guys are parallel, it would mean that this angle equals this. That would mean angle F1 equals angle B. Okay, so let's see what we get with that. Let's see what we get with that. So we're looking at 8.2.1. Okay, let's get started. Right, I'm cleaning up to make sure you can see very well. We established to be able to prove that F1 equals B to show that they're parallel, so these will be corresponding angles. Right, so now we're going to start by saying angle F1 at this point is equal to angle D1. Is the reason is that we have the 10 chord. Ten-chord theorem. So we have that F1 is D1. And the 10-chord theorem, because we assume that it's a circle that passes through these points, and therefore this one is a tangent. If this is true, you have therefore that the angle between a tangent to a circle and a chord equals the angle in the opposite or in the alternate segment by the 10-chord theorem. So F1 equals angle D1. Now, angle D1 is equal to angle B. Why? Because it was given that way. Angle D1 is equal to angle B. They marked them equal, but also they said angle D1 equals B. Therefore, the conclusion is that angle F1 is equal to angle B. So now we then have FG is parallel to BC. The conclusion is therefore that if G is parallel to BC, corresponding angles equal. The reason is FG is parallel to BC, corresponding angles equal, and this is what we had to prove. We had to prove, giving reason that FG is parallel to BC, and we've just established that. So we're in business now. We're on track. And look at 8.2.2. If it is further given that AF over FB is equal to 2 out of 5, and you have those results there. So let's analyze this one. So you have been given that AF over FB right. So you've been given that AF over FB, AF over FB is equal to 2 over 5. And you have that AC is equal to 2x minus 6. Okay. Yes, A and yes, C. That one is 2x minus 6. You have that GC is x plus 9. GC is x plus 9. But we have that AC is 2x minus 6. Okay, and also you have that AF over FB is 2 to 5. Okay. Right, so that is the question. That is the question. So then calculate the value of x. Okay, this is a very easy question. So we can start like this. So we can realize that angle side GC over AC. GC over AC is equal to FB is equal to FB over the GC over AC is equal to FB over AB. Okay, let's look at these. This is ratio, similarity, and proportionality. So because we're given the sides here, and we're going to use them. So we take GC. So it means you must take FB. So is GC over AC. So you must take, for GC, you must take FB over. Now the AC part is the same as the AB part. So this is fine. Why is this true? It is true because of the line parallel one side of triangle. So GC AC. GC is x plus 9 in red. AC is 2x minus 6. FB. FB. Okay, we have been given FB. Right, so FB is 5. Here, 5 over. What is AB? 7. So you cross multiply here, which means you have 7 into x plus 9 is equal to, you cross multiply, 5 into 2x minus 6. 7x plus 63, 10x minus 30. So 10x minus 7x would be 3x. 63 plus 30 is going to be 93. You divide both sides by 3. 93 divided by 3 becomes 31. And therefore, this is the answer. Okay, the question was obviously you had to determine the value of x, and we have found the value of x there. Question 9. Okay, in the diagram, O is the center of the circle. Points. So we're looking at the solution to question 9 right now. All right. So in the diagram, O is the center of the circle. Points S, T, and R lie on the circle. Chords S, T, S, R, and TR are drawn in the circle. You have ST, you have SR, you have TR are drawn in the circle. QS is a tangent to the second at S. QS is a tangent to the second at S. Okay. We continue. Use the diagram use the diagram to prove the theorem which states that QST is equal to R. QST equals R. Okay, so to prove this one, so we're looking at the solution to 9.1. So we construct here a circle like this, and we draw a tangent line, and we draw another chord here. We draw a chord here. We drop another chord here. We see this and the fact that this is so good. We're gonna construct here. This is the center, and then we construct like this. So this is T, this is R, this is S, and this is Q. This is the center O of the circle. Right, so we have this. We have this construction. So when you answer the exam question here in metric, you need to make sure you include the following. So you include the construction part. What is the construction? So you can include the construction. Right. Draw diameter KS, and so we have drawn diameter KS. Diameter is the line from through the center. See the circumference KS joining the points K and S. And draw KR. You draw KR, or you join the points K and R. So that is the construction there. So at this point, we're in a position to proceed with the proof and say angle QST. Angle QST. QST is equal to 90 degrees minus TSK. QST is 90 degrees minus TSK. Okay, this angle is 90 degrees because a tangent is perpendicular to a diameter at the point of contact. So in other words, the reason for this is that tangent is actually perpendicular. We can say radius is perpendicular to the tangent. So you have SR K. SRK. SRK is 90 degrees. Angle in semi-circle. SRT SRT SRT, angle SRT becomes, so in other words, you're saying SRK is 90 degrees. This angle here is 90 degrees. SRK is 90 degrees, an angle in semicircles, an angle subtended by a diameter. Because in mathematics, if you have a circle like this, a line through the center, it will always subtend an angle of 90 degrees at circumference. And this is angle in semicircle. So SRT is 90 degrees. Now, SRK is 90 degrees. So which means SRT is 90 degrees minus KRT. SRT is 90 degrees minus KRT. Okay, so observe this statement I'm making here. Or you can say SRT plus KRT. So if you do SRT, meaning you're referring to actually this angle R, and then you add KRT to it, you add KRT, in other words, you're adding this angle here. The sum of the angles is actually 90 degrees. Okay, so you're just adding parts of these two angles here, and the sum is 90 degrees. Okay, right, so this statement I've written here is correct. Okay. But we make the observation that angle TSK is the same as TRK. Angle in same segment. TSK is equal to TRK. TSK, look at angle TSK. So now angle TSK is this one. Angle TSK is equal to TRK. TSK is equals to TRK, this one. They're equal because the angles in the same segment. So if you have something like this, you have something like this. The angles that are here are said to be angles in the same segments. So they're equal those. And that is the point we're making. Right, so let's continue and analyze this question. We're proving a theorem here, this one for 5 marks. So therefore, the conclusion is therefore QST is equals to angle R. QST is equals to angle R. That is the conclusion we're making. Therefore, QST is equals to angle R. Right. Is equal to angle R. Okay, just make that observation that angle QST is equals to angle R. So we're making the observation that QST is equal to angle R. And this is actually what was supposed to be proven. As a matter of fact, from the question, okay, as part of the question, it had to be proven there. So just obviously make that specific observation there. Make that specific observation. Okay, right. We continue with the geometry. As part of the geometry, it's very important that students are also able to analyze things we call riders, questions that involve multiple statements. So now you have this, right? So we have chord QN. Chord QN, here it is. Chord QN bisects angle MNP. There's chord QN. It bisects angle M and P. Okay, chord QN bisects the angle M and P. So these angles are equal. And intersects MP at S. MP is intersected at S. The tangent at P, meets MN produced at R. Such that QN is parallel to PR. QN is parallel to PR. Parallel, can see them. They're parallel. They've been marked that way by the examiner. So we start by saying, okay, we're just familiarizing ourselves with the shape, with the diagram. The examiner here gave us some information. It said that let P1 be X. So we have that angle P1 is actually equal to X. Okay, we can see that. Now we continue and we answer the questions. We need to determine the following angles in terms of X. Give reasons. Angle N2. Angle N2, this one, in terms of X. What is angle N2 in terms of X? All right, it is clear that the angle N2 is X. Alternate angles, PR is parallel to NQ. PR is parallel to NQ. Okay, because they're parallel, then you can see this angle is x in that one. So you have that N2 is equal to x because you have alternate angles. So we found an angle that is equal to x. Determine the following angles in terms of x, and you need to give you reasons. Angle Q2 in terms of x. Angle Q2 in terms of x. So we can make the observation that angle Q2, this is 9.2.1, the A part, and we're looking at the B part, 9.2.1b. So we can see that also angle Q2 is equal to x. Why is angle Q2 equals to x? Tanko theorem. Because in mathematics, when you have this, and then you have a tangent like this, and then you have this, it is important that you have this. If you take the angle between the tangent to a circle and the chord equals the angle subtended by this chord, and this chord here subtends this angle here, and it subtends angle Q2. And the observation, therefore, is that angle Q2 is x because of the tan chord theorem. Okay. We continue. Okay, and we solve the questions. Now we are looking at another geometry question, 9.2.2. Proof giving reasons that mn over nr, let's see now. Proof giving reasons that angle mn is equal to nr. Right, so proof giving reasons that n over nr is equal to ms over sq. Okay, and the marks are 6 for that one. Okay, let's just go through the arguments here. First things first, we make the observation that mn over nr mn over nr mn over nr. Right, so we're taking mn over nr must be equal to ms over sp. Okay, this is a theorem like this. And then, so we use this theorem, for example. So if you look at this theorem very carefully, if this is m and N here, MNR, and this is SP. So you have MN over NR is MS over SP. Okay, because these are parallel. I've just redrawn this one. This is part of that. Just this triangle, I've just sort of redrawn it, not to scale, of course, but we are making the observation that from this theorem, Mn over Nr is equal to Sp over Ms over Sp. Well, the reason is that Qn is part of this, and this is the proportionality theorem. So after these, then you have N1, N2, N1, N2. So we make the observation that angle N1 is equal to the angle N2 because we're told of the fact that there's bisection. So N1 is equal to angle N2 is equal to X. Okay. Because we have found that N2 is X, so which means N1 is equal to N2 equals X, and these angles were given to be equal to each other. Angle P3 is equal to X. Angle P3 is equal to X. Why is angle P3 equal to X? Why is angle P3 equal to X? Because you can see, therefore, this angle here. So in mathematics, if you have this circle, and then you can have a chord there, this and that are drawn, this angle becomes equal to this angle, and then we say the angles in the same segment. So P3 is equal to X. The angles in same segment. So P3 is equal to, so we've seen that this one is X. This is X, and that obviously is X. The implication is therefore is that P3 must be equal to Q2. P3 is equal to angle Q2 because they're both equal to X. Both equal to X. Now you have that angle SQ angle SQ is equal to SQ. The line segment SQ is equal to PS. We make that observation that SQ is equal to PS. Sides opposite equal angles. Sides opposite equal angles. SQ is equal to PS. Why is SQ equal to PS? You have seen that this one here, Q2 is X and also P3 is X. So obviously we make the observation that this is the case. Therefore, SQ is equal to PS because their sides opposite equal angles. The base angles there are equal to each other. Now, this observation is very, very important. That SP or PS is equal to SQ. So you can come therefore and say MN over NR over NR MS over SQ. And this is just substitution, this. It is substitution. And that concludes 9.2.2. The next question is question 10. Right, so let's look at question 10. Question 10 is a very interesting one. In the diagram, a circle passes through DBE. DBE. Diameter ED of the circle is produced. So this diameter that is through the center is produced to C. So you produce it, you extend it to C. And AC is a tangent to the circle at B. AC is the tangent to the circle at B. So this AC touches the circle at the point C. At the point B, excuse me, touches the circle at the point B. Okay, M is a point on DE. M is a point on DE, such that AM is perpendicular to DE. AM is perpendicular to DE. AM and chord BE intersect at F. AM and chord BE intersect at F. All right. Proof giving reasons that that FB DM is a cyclic quad. Let's see. FB. FB. DM is a cyclic quad. FBDM is a cyclic quad. Okay, very, very straightforward. Let's see that one. So the first observation in 10.1.1 is to realize that DBE is equal to 90 degrees. DBE is equal to 90 degrees. Why? Because we have an angle in semicircle. So this is 90 degrees. All right. So therefore, DMA is 90 degrees because AM is perpendicular to DE. FBDM is a cyclic quad. It's a cyclic quadrilateral. What is the reason why is it a cyclic quadrilateral? It is a cyclic quadrilateral because of the converse of the opposite angles of cyclic quad. 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 FBDM is a cyclic quad. Now, the next result is 10 points. The next question is B3. B3, angle B3 is equal to F1. You need to prove that. So we're going to look at 10.1.2. B3 equals F1. We're required to prove that. But first things first, we can see that angle B3 is equal to, which is angle B3, this one, is equal to angle D2. B3 is equal to angle D2. Why? Tangent theorem. The tangent chord theorem. The tangent chord theorem, because you can see that angle B3, this one is a tangent, because the ones obtained by this by this chord, then it subtends angle D2. So B3 equals D2. Angle F1. Angle F1 is equal to D2. F1, this one, is equal to D2. Angle F1 is equal to angle D2. Exterior angle cyclic quads. Therefore, angle B, because now you have that both angles are D2 are equal to D2, so which means therefore angle B3 is equal to angle F1. Therefore angle B3 is equal to angle F1. Angle B3 is equal to F1 because both equal to D2. And we have proven that angle B3 is equal to F1. This is what we have to prove there in the question. Okay. Now, one more question in 1.3. Triangle CDB is similar to triangle CBE. Okay, so we're gonna here work in the following triangles. We're gonna work in triangle CDB and triangle CBE. Okay, so let's just work in these triangles. First things first, we're gonna make the following observation. Number one, angle C equals C. In triangle CDB, CDB and triangle CBE. CBE. So it means what? Okay, both angles, we can see that they have the side, the angle C, so which means angle C is equal to angle C, and that is the common angle. Angle C is equal to angle C, you have a common angle. Moreover, you have that you can remove the numbering, if possible, doesn't really matter, but we need 3 points. This is point 1. CBD is CEB. CBD is CEB. CBD is CEB. Right, so obviously because this one is a tangent here, so this angle here, B1, is equal to that angle there. So CBD is the CEB, tan chord theorem. Okay. CDB is CBE. CDB is CBE. CDB is CEB. Here's the third angle, this one. Or you can say it is angle sum in triangle. So then you have the triangle CD CDB is similar to triangle. This triangle CDB is actually very similar to triangle C. Why? Because of the angle reason. So we have been able to establish that one. And now you're moving to the next question, which is 10.2.1. If it is further given that CD is 2 units, if it is further given that CD is 2 units, okay, and DE is 6 units, calculate the length of those. Let's see this one, calculate the length of BC. Okay, so let's do this one here very carefully. Okay, we are reasoning this out. So we need to put this information in the diagram and visualize what this is saying. Okay, after you have solved all this, then you'd be having your 150 marks there for the 100% in paper 2. And so now, if it is further given that CD is 2 units, if it is further given that CD is 2 units, DE is 6 units. Okay, so CD is 2 units and DE is 6 units. Calculate the length of BC. BC. Calculate the length of BC. Let's see that one. So now to do this one here, we make the following observation. We remember this in this case in 10.2.1. The CD they're mentioning relates to this, and then the DE they're mentioning appears to feature CD. Obviously, you can see that appears there, and then you would have your DE. So, for example, if you look at the CDB we just saw, and then the other one, CBE, CBE. Okay, you sketch this one. Okay, so we have those two shapes. And then if the examiner makes mention of the side DE, for example, you can see that it is part of the triangles of interest. And hence in 10.2.1, we make the following observation that BC over EC, BC over EC, BC over EC is equal to DC over BC. Why? Similar triangles. BC over EC. Okay. Is equal to DC over BC. C, okay, I want to analyze this very well. I want to relate these to practicality. So you have BC, BC over EC. Sorry. This is true because of the similar triangles. Because now if you have the triangle C, DB, and this is similar to triangle CBE. And then now at this point, you can have some relations like you can have, if you take the first two, like you can take CD over CB is equal to the last two, DB over BE equals CB over CE. Okay, let's look at this. So you have BC over CE, and then you have CD over BC. So yeah, from the similar triangles there, we saw this one in question, we proved it in 10.1.3, it was proved there. Okay. Now we continue to analyze this. 10.2.1. We cross multiply here, and if we do that, we have BC squared is equal to EC times DC, which is 8 by 2, which is 16. Which means BC squared is equal to 16. Okay, so if BC squared is equal to 16, what do we get? So, which means BC squared is equal to 16. You take the square root on the left, square root on the right, which means BC is equal to 4 units. BC equals 4 units. And they asked us here to find the length of that. The length of BC is 4 units. The next thing now we're going to do is to look at 10.2.2. Want to find the length of dB. Want to find the length of dB. The length of dB, we already know that the length of BC is 4 units. Okay, so in 10.2.2, we're looking for dB. So we note from the similar triangles like we saw, that the since triangle CDB is similar to triangle CBE. And this has been proved in the other question 10.1.3 above. Okay, how significant is this? Well, it is very significant because of the following. You can take CD over, those triangles are similar, so you take the first two, CD, you divide by CB, you take DB, you divide by BE, you take CB, you divide by CE. So make the observation that we have this one here and this one. So you have that BC is equal to which means dB is equal to dB over BE. Let's look at the shape now. dB, where is dB. Right, so you have D here and B there. And then you have BE, B here, and E there. Okay, so what can we observe out of this? dB over BE. Okay. dB over BE, BC already got 4 units. CE already got. CE already got. This is 8 units. This is C and this is E, so it's 8 units. And this is 1/2. We cross multiply these things here. And then we get that BE is twice dB. So which means dB squared, is equal to what? Right, so we check dB squared. What is it equal to in this case? So we analyze the shape very carefully. Right, so analyzing the shape very carefully. In 10.2.2. Right, so we make the observation that dB squared plus BE squared is equal to DE squared. And this is the Pythag theorem. So you get the shape again, make sure you understand this. That DE squared clean this up. That's DE squared. This is a right angle triangle because it's an angle in semisecond obtained by diameter. So DE squared is equal to DB squared plus BE squared. So you have a right angled triangle there. Pythagoras theorem. This observation is very important because it means dB squared